In this video, we're going to take a look at some mixed factoring. Now that we've learned all the different techniques, we're going to try to see if we can figure out which technique is the right one for each problem. Okay. Now we should sort of think about our approach instead of just randomly trying them, although sometimes certain ones just kind of leap out at you. I think we should have a strategy, and the strategy I like to use is to always look for the GCF first. Okay, then I take care of any GCF, understanding that even after the GCF is done, I might have more to do. Then I look to see if it's an a squared minus b squared scenario. That's the difference of squares. Right? If that doesn't fit, then I look for the x squared plus bx plus c pattern. That's the trinomials, where you're looking for two numbers that add to b and multiply to c. Right? And then the fourth technique, if you happen to have four terms, would be when you look for the grouping. Okay? So if you had a bunch of these together on a test, maybe before you got into, or even on a quiz, maybe even homework, maybe the best thing to do is before you get into any of them individually is to kind of take a quick look at each one and see what technique works. So when I look at this first one, I certainly see a GCF. Okay. The GCF here is X, and you could always go ahead and finish it now, or you could try to go through all of them, make a quick note, and then try to finish it later. The one thing to keep in mind is that sometimes when there's a GCF, there might be a second step after that. On this first page, I only have the one-step factoring problem, so if there's a GCF, that's all you're going to do. When I look at this next problem moving down, this one also has a GCF. It looks like it's going to be 5x here. Okay. This next one here, I don't see a GCF, right? I always go through my list and look for the GCF first, but I don't see a GCF. Right, so then I look for a difference of squares, and it does fit that pattern. Right? This looks like an a squared minus b squared pattern, right? Because a squared is a perfect square and 16 is a perfect square. Okay? So if you can be sort of systematic about it, you can take some of the maybe mystery out and feel a little bit better, like you're working towards the goal. When I get to this one up here, the x squared plus 10x minus 24, there's no GCF. It's not a difference of squares, but it does fit this pattern. So I'm going to have to hope I can find two numbers that multiply to 10, add to 10 and multiply to negative 24. Again, I'll deal with that part later, right? But that's where I want to start. So this will be the trinomial. I'll just put a little trinomial part there. This next one down here, I can see a common factor, so I'll say GCF. Right, my pen's still giving me trouble, but we'll do the best we can. And then this next one, it's not a GCF, it's not a difference of squares. It does fit this pattern again. Right, here we go. I didn't put any grouping on in this video just because they're a little bit less common in general, and they sort of stand out as four-term polynomials. If the only option with a four-term polynomial would be either the GCF or grouping. Okay, so for this video, we're going to not deal with the grouping, even though technically we should always think about it. Okay, so actually let me get rid of these last few marks, then I can erase this here. And now that we've gone ahead and sort of figured out what the strategy is for each of these, let's just go ahead and finish them. So going back to this first example here, x squared minus 8x, the GCF is x. So we're going to take the x out. We're going to have two terms left behind, x minus 8. Right? Again, it's probably worth in your head at least just sort of working this out, making sure you get everything back the way you were supposed to. Looks good. Okay. When we go to this next problem over here, the GCF is actually going to be, let me just erase that. That's maybe a bad choice. The GCF would be 5x. Okay. So when we go to solve this one, we'll take the 5x out. We're going to be left with an x squared minus 4. Okay, and I actually am mistaken. This one actually does require 2 steps to finish factoring. Okay, because if you take a look at the x squared minus 4 here, right, that fits this pattern here. So I sort of meant to hold off on those, but it's here, so we might as well deal with it. X squared minus 4, I'm going to need a little bit more room now. Take this out. X squared minus 4 fits that pattern over here of a squared minus b squared. Circle's a little bit in the way. Let's try this again. Alright. So when you have a squared minus b squared, you're always going to get 2 parentheses. The first 2 have to multiply, in this case, to the x squared. The last 2 have to multiply to the 4. And the key is they have to be the same number. You make one of them plus and one of them minus, and then this 5x that was in front still needs to be in front. So this would be your final answer. I was sort of waiting to hold off on that, but I put it in here by accident, so we'll go ahead and live with it. You always start with the GCF. After you take the GCF out, you might find that there's something left behind that can be factored, and that's what happened here. This next one over here is actually a little bit easier because it's just the GCF. I'm sorry, it's just the difference of squares. And again, once you realize it's a perfect square here minus a perfect square here, you can just fill in what it takes to make each perfect square. A times a is a squared. 4 times 4 is 16. Make one of them minus, one of them plus. It doesn't matter what order you do that. Right? That's the answer you have. Okay. So there's always sort of 2 steps to this. First is knowing what you're supposed to do. Is it a GCF? Is it a difference of squares? Is it a trinomial? And then the last part is going to be actually finishing the process and doing it. We look at these 2 here. These are the trinomials. Right? Those are the ones where you need 2 numbers that multiply to one and add to the other. Okay? I'm not going to take the time or the space here. I don't really have it right here to work this out. But if you think about it and you start with the 24, there are 2 ways to get 10 with 24. 6 plus 4 makes 10, and 6 times 4 makes 24. But since it's a negative 24 here, right? That didn't look very good. Since it's a negative 24, you're going to have to subtract. So you're going to actually have to use 12 and 2. So we sort of did this a little bit longer setup where we would have written out the 2 blanks, gone through all the factors of 24, and tried to find a pair of factors that in fact adds to 10 and multiplies to negative 24. And it would have been a positive 12 and negative 2. That's where I got this positive 12 and negative 2. But in this section, I really wanted to focus on what were the different techniques and how did they look side by side. Every single one of these requires its own work that was discussed in an individual section and individual videos. Okay, so if you did have a little bit of trouble getting through this, then you need to go back and look at factoring those trinomials, see that you can set up the blanks and fill them in properly. Okay, this next one over here has a GCF of 3x, right, which is going to leave behind an x to the 4th minus 12x squared plus 9, right? And there's no way to factor this. Okay, there's no numbers. It's a trinomial. It is x to the 4th, and there are ways you might learn to deal with those later in another course. But even so, this one won't work. When we get to this last one, again, we're going to look for 2 numbers that add to negative 11 that multiply to 18. Right? The choices for 18. I'll do this one because I have a little more space. 1 times 2, 2 times 9, 3 times 6. And if I'm going to get 11, I better use 2 and 9. So it's going to be y minus 2, right, and y minus 9. Okay? So all this section is really taking all the different types of factoring you had before and putting them all together. I think the key is having a strategy. Start with the GCF, look for the a squared minus b squared, and then look for the trinomials if neither of the other 2 patterns fit. understanding that just because you have a GCF doesn't mean you might not have something else to do too. Okay, so it's important that you put a few of these from different sections side by side, right, or go to a section where they're all mixed together like we have in our textbook. But there's, you first have to know how to do each one individually, and then you have to know what they look like so you can pick the right technique for the right problem. Okay, so this next page has a few more. Some of these are similar, some of these are different. With this first one, we're going to start with the GCF. Okay, it might look like a difference of squares, which is why I picked 16 over here, right? And that's where, if you don't really have a plan or a strategy, you might sort of go down a wrong path and look at the wrong thing. While the 16 is a perfect square, this x over here isn't. So before you get sort of ahead of yourself, you should be thinking GCF, and in this case, the GCF is x minus 16. There's not really anything else to do. Okay, if it was x squared minus 16, then we'd have more work to do. Okay. For this second one here, the GCF again is 5, or there is a GCF, it's 5, and it's going to be x squared minus 4. And what we just learned from the previous example is that x squared minus 4 fits the difference of squares pattern. So the x squared minus 4 in its own, right here, can be broken down, but the 5 still comes down to get back to the original 5x squared minus 20. Okay, this next one looks like a difference of squares except for one important distinction here, right? This is a plus. And you could play around with it. You could try a plus 5 times a plus 5, which may look like you're going to get a squared plus 25, but in the middle here and here you're going to not get that canceling that you did with the difference of squares. So this actually doesn't work, and we'd say that this one is prime. Right. Again, I'm okay if you say it can't be factored. Right? There's no GCF, it's not a difference of squares, it's certainly not a trinomial, and it's not factoring by grouping. Okay. We've got two more to do here. This one here, you're going to start with the GCF because there is one. The GCF is 3. So we're going to take the 3 out. We have x squared plus 5x minus 6. And now we have to look at the factors of 6, right? 1 times 6, 2 times 3, and we have to make 5. Now both of these pairs of numbers make 5, one by adding, one by subtracting. Right, remember, the key is in the signs. If you're going to multiply to a negative 6, you better have one positive and one negative. So we're going to use the blanks here. The key is going to be to pick the 6 and the 1. We want a positive 6 and a negative 1, so that we will multiply to negative 6 but add still to positive 5. Now that takes care of what's in the parentheses here, right? But we can't forget about the 3 that was out front too. Okay, so this would be our final answer. I should sort of box our final answer over here. All right. So the two examples here with the boxes around them, right? Those are ones that first had to do the GCF, and then the part left behind had to be factored again. That's the hardest type. Most of the problems will be sort of the regular one-step factoring, but it's reasonable to expect a few of these to get mixed in, and the higher up you get, the more of this you might see in a different course. Okay, this last one here has two variables in it, which certainly complicates things, but it's not really as bad as you think. If you sort of forget about the y's temporarily, because they that didn't really work well. If you sort of ignore the y's for the time being, right, and think about what you would do with x squared plus 8x plus 12, you can still sort of see the trinomial that's here. I can ignore the y's because they fit the right pattern. There's a y in the middle and a y squared on the end. We have this sort of symmetry of x squareds at the front and y squareds at the end. But again, over here, you're looking at 12, a trinomial, 1 times 12, 2 times 6, 3 times 4. Right, and you're going to focus on the 2 times 6 that makes 8. So if the y's weren't there, we would just say x plus 6, x plus 2. I realize I said 2 and 6, but the order doesn't matter. Okay. The reality is, however, that the y's are there. So how are we going to deal with that? Well, it's actually not that complicated. If I stick a y over here and a y over here, what'll happen is there's my 12y squared. 6 times 2 is 12. Y times y is y squared. Okay, if I look over here, I have a 2xy, and over here I have a 6xy. When I put them together, I'm going to get 8xy. Okay, and I can see, hopefully, right, the x squareds are here. Right. So if you happen to see x squareds and y squareds in this pattern, don't get overwhelmed. Just sort of treat it like a trinomial. Get the numbers right. Put the x's in the front because that's where the x squareds are. Put the y's in the back because that's where the y squareds are. Okay. So as they all get mixed together, it just becomes harder to keep everything straight. I think the key is going to be focus on this order. Right. Try the GCFs, look for the difference of squares, look for the trinomials, keep in the back pocket the grouping if there's 4 terms, and hopefully with practice this can get better. And it's the kind of thing you really have to practice every day. Mix a few together, see if you can get it right.